All right, so let's take a closer look at what happens at the ribosome. At the ribosome, you have your mRNA strand with its nucleotides, A's, U's, G's, and C's. And then your tRNAs also have what's called an anticodon on them. And that anticodon will match a codon on the mRNA strand. And so you got to remember that these sets of 3, these are called a codon, and this set of 3 is called an anticodon. And so basically, we're looking for a tRNA that matches, so this UUC, U would bind to A, so we have an AAG we're looking for. So this is the only tRNA that can bind here. It'll come in, bind here. These, let's just show you that one. These proteins, this growing polypeptide chain, once this sits down, they will bind together, and then this RNA or tRNA that is at the end here, that's going to go off and do its own thing. Okay, and so your ribosome then just moves down the strand of mRNA, continually adding more tRNAs, more amino acids until they reach the end where there, or part of the mRNA that there is a stop codon. That'll signal that the protein is finished and will release the protein to go do what it needs to do. Okay, so if you look at this in terms of code, we talked about how this is sort of the central dogma of biology, about how this whole idea of DNA resulting in proteins that make up the individual organism, this is like the whole thing about biology that's built around, okay? Now, we can actually look at the code here, though, and follow it all the way down. The base pairing rules are the same. A binds with T, A binds with U in RNA, and this one's in DNA, obviously, and then G binds with C, okay? So if I'm gonna make an mRNA strand from my DNA strand, I'm just gonna go through and follow the rules. So T is going to bind with A is going to bind with U in this case because we're in RNA now and we don't have T's, we have U's. C is gonna be a G, A is gonna bind with U, A is gonna bind with U, G is gonna bind with C, A binds with U, T's bind with A's, okay? And now you're gonna look at this as codons, okay? So these are our codons. Now you can also, you can read, there's lots of different wheels and or charts that show you the mRNA code and which protein will be with it, okay? But you can also look at what tRNA is, what the anticodon is going to be. So like if my mRNA strand down here is this code, what's going to be on my tRNA, okay? So you can do that. Let's do green here. So if I have an A here, I'm going to have a U on my anticodon. If I have a U here, I'm going to have an A, G, C, U is going to be A, C is going to be G, U is A, and A's are going to be U. Okay, so these are the tRNAs with their anticodons. Okay, and now your POGIL that you're going to do today is going to show you how to read the charts, and we all know, because scientists have figured out which code brings which protein, okay? So I've already looked this up, but basically you're going to look up UAC, and UAC codes for methionine, right? Each 3 nucleotide code codes for 1 amino acid. So then AAG stands for phenylalanine, and then I made this short so that AUU codes for a stop codon, okay? So most all new strands are gonna be brought with methionine because that's also a start codon or initiator or promoter, they call it. And then this can be like hundreds of amino acids long until it gets to a stop, okay? So hopefully that helps you with that POCO, with knowing how to go through the code and what it's telling us. So basically, locked away in your DNA tells us which proteins get made in which sequence and how they function, okay? All right, guys.